Section 1.2, applications of linear equations in one variable. So some rules of word problems. Step 1, read the problem carefully. I know people don't like word problems. Step 2, assign labels to unknown quantities. Step 3, create a model in words. Basically, write it out in sentence form. Step 4, write a mathematical equation. Now it's when we're changing it to write the actual algebraic parts. Step 5, solve the equation and check. So before we can do any word problems, you need to know some key terms that represent certain phrases. So like addition, if I want to see A plus B, you can see the phrase, the sum of A and B, A plus B, B added to A. So if B is added to A, that's A plus B. B more than A. So it means A had to come first, then the B. And these are the ones that are used a lot in word problems. B more than A. A increased by B. The total of A and B. Subtraction, if I want to show A minus B. The difference of A and B. A minus B. B subtracted from A. A decreased by B. B less than A. The ones that are starred are important because they're the ones used significantly in word problems. Multiplication, A times B. So if you see the word the product of A and B, A times B or A multiplied by B. Division can be seen as A divided by B or A over B. So if you see the phrase quotient, when they talk about quotient, it's A over B. And it's whatever you see first. If it says A and B, A is the numerator, B is the denominator. If it said B and A, then B would be the numerator, A would be the denominator. So this is left to right. As you see it, left to right is how you would write your situation. So here, B divided into A. B divided into A means A split B times. The word ratio of A to B, A over B or A per B. If you see any of these phrases for all of these are your word problems. So going on to our first example, when we look at the problem, it says the sum of two numbers is 39. One number is 3 less than twice the other. What are the numbers? So let's look at some key phrases. They said the word sum. They said the word less than. They said the word twice. So when we come to a problem like this, we need to come up with situations. So they're saying the sum of two numbers. So we have a number 1 and a number 2. So I can say that the first number plus the second number, they said the word is, that means equals 39. There's one setup. So now we need to come with terms. So I'm saying the number 1 is the variable x, the number 2 is the variable y. Next thing, it says that one number is 3 less than twice the other. So we're going to make a choice. I'm going to say the second number. So the second number is equal to, it says 3 less than twice. Remember when it's words less than, this is the second term, this is the first term. So it's going to be twice the first number minus 3. So now change these to represent the variables. Well, the second one is actually the letter y. The first one is the x minus 3. So I have y equals 2x minus 3. Now, we already had our setup here. It says the first number and the second number equals 39. So now we're going to use substitution. Well, the first number was an x. The second number was a y equaling 39. But y, see here at this point, we can't do x plus y equal to 39, but we know that y is equivalent to 2x minus 3. So we have x plus 2x minus 3 equaling 39. Combine your like terms. So have an x with another 2. There's 3 of them. Minus 3 equaling 39. Add 3 over. 3x equals 42. Divide by 3. So x is equal to 14. That is the first number. So we know that the first number is equal to 14. We need to know what the second number is. Well, it says that the first number plus the second number is 39. So the second number is 39 minus the first number. So 39 minus 14 and you get 25. So your two numbers are 14 and 25. Example 2. It says 3 times the sum of two consecutive odd integers is 516. Find the integers. The first thing, it said the word consecutive odds, and they said the word sum and then 3 times. Well, first thing, we need to know what a consecutive odd integer is. So consecutive integers, think of the number ordered 1, 2, 3, 4. They are in sequential order. So when we write it algebraically, the first number represents x. The next one is x plus 1, x plus 2, x plus 3, continuing. And here's an example. If x is 1, then 1 plus 1 makes it 2. 1 plus 2 is 3. 1 plus 3 is 4. So it follows the pattern. Consecutive even or odd integers. If they want an even pattern, 2, 4, 6, 8, continuous. So the first term represents x. The second one's not going to be x plus 2. Third one is x plus 4. Fourth one is x plus 6. So if x is 2, then 2 plus 2 is a 4. 2 plus 4 is a 6. 2 plus 6 is an 8. So they go in pattern order. If I am odd, 1, 3, 5, 7, etc. The first term is x. The second term is x plus 2. The third term is x plus 4. The fourth term is x plus 6. So the first number was 1. Then 1 plus 2 is a 3. 1 plus 4 is a 5. 1 plus 6 is a 7. Notice that consecutive even and odds have the same algebraic setup, but it's dependent on which number you start on. If you start on an even number, the pattern stays even. If you start at an odd number, the pattern stays odd. So it says here, 3 times the sum of two consecutive odd integers is 516. So we need to come up with our thing. It says 3 times. 3 times. It says now the sum of two consecutive integers. So the first two terms, x plus 2, and it says that is your equals 516. Now, before you distribute the 3, notice that the right side has a plain number, and the 3's outside by the product rule. Easiest way to do this is divide by that outside number. So now we see x plus 2 equals 172. Now combine like terms. So I get 2x plus 2 equals 172. Subtract 2 over. So 2x equals 170. Divide by 2. So x equals 85. Now, remember, it said two consecutive, which means they need to be consecutively ordered. So the first term is x, which is 85, then 85 plus 2. The second term is x plus 2. So 85 plus 2 makes it 87. So your two numbers are 85 and 87. If you add the two numbers together, you get 172, which then you multiply by 3, which gives you your 516, so the reverse order. Example 3, a woman invests $5,000 in an account that earns 5.5% simple interest. If the money is invested for 3 years, how much money is in the account at the end of the 3-year period? So on this problem, I gave you the simple interest formula. Simple interest says I is equivalent to PRT. I represents interest, P is principal or amount invested, R is the rate in decimal format. So if they gave it to you in percent, you need to change it to decimal points. T is time and it's in years. So if they gave it to you in days or weeks or so years needs to be used. So if you have days, divide by 365, weeks divide by 52, months divide by 12, such forth. So in this one it says the woman invested $5,000. When you identify our key terms, it says invest $5,000. So that means that is our principal. We invested $5,000. It says she earns 5.5% simple interest. So the rate is 5.5%. But remember, we need to make this decimal format. So now I see 5.5%, but I still have percentage. you need to divide by 100 so you can get it to decimal format only. So we get 0.055. Then it says the money is invested. Example 3, a woman invests $5,000 in an account that earns 5.5% simple interest. If the money is invested for 3 years, how much money is in the account at the end of the 3-year period? So first thing I'm giving you is a simple interest formula. It says I is equal to PRT. Well, I represents interest, P is the principal, R is rate in decimal, and T is time in years. So rate in decimal, if they give it to you as a percentage, you need to convert it to decimal only. Time is in years. If it's not given to you in years, you need to get it to years. So if they gave you days, remember, divide by 365 to convert it to years. If they give it to you in months, divide by 12. They give it to you in weeks, divide by 52. So first thing they do, they tell you they invest $5,000. So our principal amount is $5,000. It says earns 5.5% simple interest. So that means our rate is 5.5%. Now, convert this to a decimal. We get 5.5%. But remember, we're still in percent. We need it in decimal format only. So you're going to divide by 100 to get 0.055. Time says 3 years. So they gave it to you already in years. We're good there. So now what we do is it says how much money is in the account at the end of the 3-year period. So first thing we need to do, we need to find our interest. So you can write your formula, I equals PRT. Our interest earned, so our principal is $5,000, a time frame at a rate of 0.055 in a time frame of 3 years. So using your calculator, 5,000 times 0.055 times 3 results in 825. But it says after the 3 years. So remember, you need to do your principal plus your interest. So 5,000 plus your 825 is 5,825. Example 4 says a college bookstore uses a standard markup of 40% on all books purchased wholesale from the publisher. If the bookstore sells a calculus book for $179.20, what was the original wholesale cost? So first thing, we need to identify specific things. So they said standard markup of 40%, which means they're adding to the base price 40%. They tell you that it sold the book for $179.20. I don't really care that it's a calculus book. It's just the money amount. They want to know what was the original. So original is when it was at 100%. So what we are going to do is set up a ratio. First thing you're going to do is going to come up with a thing, setup. So original price over original percent is equal to sale price over original plus markup percent. So we're going to do original price over the original percentage equals the sale price over the original plus markup percentage. So first thing, original price, we don't know what the original price. We're going to label that X. So we're going to write X over, well, original percentage, well, it's always going to be out of 100 because it's 100% is whole, equals sale price. The sale price, the calculus book was being sold for $179.20, so I'm going to write $179.20 over. Now it says original plus markup percentage. Well, the original percentage was 100, and I marked it up 40, so I'm 140. At this point, you can do the product of the means with the extremes or multiply both sides by 14,000, does regardless. I'm going to multiply diagonally. So this side is going to be multiplied by 140, this side by 100, and those go away. So you get 140x equals, you're moving the decimal place over twice, so you get 17,920. Then divide both sides by 140. So 179.20 divided by 140 gives us 128. So the calculus book was $128 before they marked it up. Example 5 says, Miguel had $10,000 to invest in 2 different mutual funds. One was a relatively safe bond fund that averaged 4% return on his investment at the end of 1 year. The other fund was a riskier stock fund that averaged 7% interest return in 1 year. If at the end of the year, Miguel's portfolio grew to $10,625, which means $625 above his $10,000 investment, how much money did Miguel invest in each fund? So first thing we need to understand is he said he had a safe bond at a 4% return and then a riskier stock at a 7% return. That his interest was $625 earned. So I'm going to come up with some scenarios. The safe bond is going to represent X. The riskier one is going to be the Y. Interest earned was $625. Total investment was $10,000. And the time frame was 1 year. So easiest way to do this is do a chart and using your rates as your starting points. So we had a 4%, a 7%, and a total. Remember, the first line is going to represent the accounts because they told us that we had 2 different accounts. The second line is going to be your interest because we're using percentages. So since I said the 4% represented the safe bond and we don't know how much money invested, we have X. The 7% is the riskier one, that's the Y. And the total was $10,000. Interest. Now, noting these percentages at the top, you're going to use that for multiplication down. So we're going to write 4% with an X, 7% with a Y, 625. Okay, now remember percent. So we're going to we have 2 equations coming up. We have X plus Y equaling 10,000. 4% X plus 7% Y equaling 625. Since systems of equations have yet to be introduced, we're going to say that the Y equation, by moving the X over, is $10,000 minus X. So wherever the Y, so now this one doesn't give us a result, so I'm looking at the percentage one right here. 0.04x in decimal format plus 0.07, and we said that Y is 10,000 minus X, so 10,000 minus X equaling 625. We're going to use the distributive property, so 0.04x, 0.07 times 10,000 is 700, 0.07 times X, negative X is negative 0.07x equaling 625. Combine your like terms. So I have 4 pennies. I took away 7 pennies. I'm negative 3 pennies. Plus 700 equals 625. Subtract 700 over. Yes, it's going to give you a negative answer. But remember, we have a negative value at the beginning. So I'm $625. I spent 700. I'm short 75. We're dividing a negative by a negative. Remember, you do not add your X. Do not add X here. You're dividing by your number coefficient only. So X equals negative 75 divided by negative 0.03. It's a positive answer, so we get 2,500. So remember, X represented the safe bond. So we said that X plus Y equals 10,000 Well, we know that the X is $2,500. The Y is what we're trying to find. So 2,500 plus Y equals 10,000. Subtract 2,500 over. So Y is 7,500. Example 6, how many liters of a 40% antifreeze solution must be added to 4 liters of a 10% antifreeze solution to produce a 35% antifreeze solution? So those of you in chemistry, think of your chemistry equations, balancing the equations. So first says, how many liters of a 40%? We have a 40% solution that we're adding to a 4 liters of 10% to produce 35%. So the percentages are your headers. So we have a 40%, then we're adding 10% to yield a 35% response. So first thing, 40%, we don't know what it is, so I'm gonna say that's X. 10%, they tell you have 4 liters. 35% is our unknown. So we're gonna write X plus 4 equals, well, the bucket 1 plus bucket 2 is bucket 3 combined. So 35% is your X plus 4. The next one is, remember, percentages are here, so we're multiplying them down. So we have 40% X plus 10% times 4 equals 0.35 times X plus 4. Here's our equation. So we're going to have 0.40 X plus 0.10 of 4. So 10% of 4 is 0.4, equaling, we're going to distribute. So 0.35 X plus 0.35 of 4 is 1.4. Subtract the 0.35 X over. So you're getting a nickel X plus 0.4 equals 1.4. Subtract the 0.4 over. So a nickel X equals 1.0. Divide both sides by 0.05. So X equals 20. That's 20 liters. So we know that we're putting 20 liters of 40%. So 40% is 20 liters. We know that the 10% is 4 liters. So the 35%, there is a total of 24 liters involved. Example 7 says, a hiker can hike 1 mile per hour faster downhill to a moose lake than she can uphill back to the campsite. If it takes her 3 hours to hike to the lake and 4.5 hours to hike back, what is her speed hiking back to the campsite? First thing we need to know is that this one's going to involve distance equals rate times time. Those can represent your headers of your chart. So we have a distance, we have a rate, we have a time. And then they told you directions. We went uphill and we went downhill. So first thing I noticed, they said that the hiker can hike 1 mile per hour faster downhill than they can uphill. So downhill, uphill, we're going to use X to represent our rate. Downhill, you're going 1 mile per hour faster, so it means X plus 1. It says it takes her 3 hours to the lake, 4.5 back. So downhill is going to take us 3 hours. Back up to the campsite is 4.5. Distance, remember it says distance is equal to rate times time. So rate times time, we have 4.5x. And if we multiply this, we get 3x plus 3. So remember, we have two equations here. But remember, distance. The distance to the lake is equal to the distance to camp. It doesn't change. You don't deviate. So we're going to say that uphill distance equals downhill distance. So 4.5x equals 3x plus 3. Subtract 3x back over. So you get 1.5x equals 3. Divide both sides by 1.5. So x equals 2. So the rate uphill equals 2 miles per hour. Rate downhill is 2 plus 1, which is 3 miles per hour.